This is the screencast for section 4.4, modeling and optimization, which, yes, does involve word problems. All right, so example 1 says, find two numbers whose sum is 20 and whose product is as large as possible. Well, that large as possible thing gives me a clue. Large as possible is a maximum. So I want to maximize the product. So I might say something like P equals, and it's going to be one number times the other number. So their product is as large as possible, but whose sum is 20. So that means if I call one of these numbers x, the other number is 20 minus x. So the leftover. So in other words, if x was 2, 20 minus 2 is 18. So 2 times 18. But I'm trying to maximize their profit, or their product. So that's what I'm going to do. I'm going to take the derivative and find its maximum. So I got that the derivative of the profit was 20 minus 2x, which has a 0 at 10. And then I tested the number line, and I see that I get 10 as my maximum of the profit. So therefore, my two numbers are 10 and 10. And the profit is 100, or the product is 100. The now try problem number 1 is a tad bit longer than the example. So we're going to find the sum of two non-negative numbers, which is 20, and find those numbers if the sum of their squares is as large as possible and as small as possible. So that's part A. So I'm going to call the sum of their squares y. So y equals one number squared plus another number squared, and the sum of their numbers is 20, similar to the last problem. So I'll say one of the numbers is x and the other one is 20 minus x. And I want to find that their sum of their squares is as large as possible and as small as possible. Either way, I need to test the derivative and find a max or min of the sum of their squares. So I got that 10 makes the derivative of the sum of the squares of these two numbers equal to 0. And I tested that number line, and I can see that the sum of the squares has a minimum at 10. So the smallest possible square of their sums is when the two numbers are 10 and 10. And really, I could plug that in. 10 squared plus 20 minus 10 squared is 10 squared plus 10 squared, which is 200. The largest possible is going to be one of those endpoints, and really either 0 or 20 are maximums. Y is decreasing after a left endpoint because the first derivative is negative, or y is increasing before a right endpoint because, again, y prime is positive. So we've got maximums there, but it doesn't matter which one we use because if one of the numbers is 0, the other number is 20. So the largest possible sum of the squares happens when the numbers are 0 and 20. Part B has the same setup, so the sum of the two non-negative numbers is 20, so we're going to use x and 20 minus x again. But one number plus the square root of the other is as large as possible or as small as possible. So then the question is, do you put the square root around the x or the 20 minus x? Well, I don't know about you, but I don't want to do a square root around 20 minus x because finding its derivative is going to involve the chain rule. I'm going to put the square root around the x and leave 20 minus x alone. It doesn't matter because if I take the square root of the smaller number, let's say 2, the bigger number is going to be 18. If I take the square root of 18, the other number is going to be 2. So it doesn't matter. The square root will find one number, and then the 20 minus x will find the other number. So again, we're going to find where this is as large as possible and as small as possible, so I need the first derivative. And after some messy work, I find that the number that makes the first derivative 0, so the sum of the one of the numbers and it's the square root of the other, 0, is going to be 1/4. So I'm going to test that on a number line. And I do get that 1/4 has a maximum of y because the first derivative changes from positive to negative, meaning the original changes from increasing to decreasing. So the largest possible sum of one of the numbers and the square root of the other is when x equals 1/4. So the number I'm taking the square root of is 1/4. The other number then would be 19 3/4. And if I plug in 1/4 for x, I do get, I think, 20 and 1/4 for this actual sum of those two numbers, one and the square root of the other. The smallest is going to occur on one of the endpoints, and again, the ends don't matter because if one of them is 0, the other one is 20. So I can use either endpoint, which will both be minimums because the y function is going to be increasing after a left endpoint and decreasing up to a right endpoint, creating a minimum in either situation. So in that case, the smallest result would be when the numbers are 0 and 20.